Let's explore. Number 10. Venus, the closest planet to Earth. At its nearest point, 38 million kilometers away, close enough that on a clear night it outshines every object in the sky except the moon. For most of human history, it was called the morning star and the evening star, the brightest light in the heavens. Astronomers who first turned telescopes toward it in the early 20th century saw thick clouds covering its surface and genuinely speculated about what lay beneath. Tropical forests, perhaps, warm oceans, a world that might, under that impenetrable overcast, be teeming with life. Venus was supposed to be Earth's twin. Same size, same mass, similar distance from the Sun, formed from the same disk of gas and dust at roughly the same time. The expectation was not unreasonable. The reality was not survivable. In 1962, NASA's Mariner 2 became the first spacecraft to successfully fly past another planet, and the data it returned ended the speculation permanently. The surface temperature of Venus is approximately 465 degrees Celsius, not at the equator specifically, not at noon specifically, everywhere, at all times. Day and night, pole to equator, the surface of Venus maintains a temperature sufficient to melt lead. The atmosphere presses down at 92 times the pressure of Earth's atmosphere at sea level, the equivalent of being submerged 900 meters beneath the ocean. Except instead of cold water, it is carbon dioxide, heated to 465 degrees with sulfuric acid clouds above. The Soviet Venera landers sent to the surface between 1970 and 1982 survived between 23 minutes and 127 minutes before the planet destroyed them. Not because of design failures, because of the planet. The most advanced engineering humanity could produce was given a maximum survival window of 2 hours on the surface of our nearest neighbor. What makes Venus genuinely disturbing, not merely extreme but disturbing, is the evidence that it was not always this way. Climate models indicate that Venus may have maintained stable liquid water oceans for as long as 2 billion years. 2 billion years is longer than it took multicellular life to develop on Earth. A runaway greenhouse effect triggered by rising carbon dioxide levels initiated a feedback loop that erased all of it. The oceans evaporated. The water vapor added to the greenhouse effect. The temperature climbed. More water evaporated. Venus is not just a hell world, it is a demonstration. The same mechanism runs on Earth right now at a slower rate, in a system with less margin than most people realize. Our nearest neighbor crossed a threshold it could not uncross. What remained was heat and poison and silence. Number 9. Gliese, 436b, 33 light years from Earth, in the direction of the constellation Leo. There is a planet the size of Neptune where the surface temperature exceeds 440 degrees Celsius, and the interior is made of ice, not ordinary ice, Ice X. A crystalline phase of water that forms only under pressures so extreme that the molecules are locked into a dense lattice by the planet's own gravity, compressed so tightly that no amount of external heat can melt them. The surface is hot enough to melt tin. The inside is frozen solid because physics says it has to be, regardless of what the temperature says. The planet should contain large quantities of methane. According to every atmospheric model planetary scientists developed over decades. Gliese, 436b, contains 7,000 times less methane than it should. It also contains an abundance of carbon monoxide that no current model can adequately explain. In 2015, observations using the Hubble Space Telescope revealed that Gliese 436b is slowly evaporating, trailing a cloud of hydrogen approximately 50 times the size of its host star behind it, burning ice, missing chemistry. A planet simultaneously frozen solid at its core and dissolving into space at its edges. How many other things we consider impossible are simply waiting for the right planet to prove us wrong? Number 8. TRISS 2b. In August 2006, astronomers detected a Jupiter-sized world, 750 light-years away, in the constellation Draco. They named it TRISS 2b. In 2011, David Kipping of the Harvard-Smithsonian Center for Astrophysics published his analysis of its reflectivity. Jupiter reflects approximately 34% of all sunlight that strikes it. The darkest natural objects in our solar system reflect about 2 or 3%. TRES-2, B reflects 0.04%, less than coal, less than black acrylic paint, less than any planet, moon, or natural body ever measured anywhere in the observable universe. It is, by a margin significant enough to be disorienting, the darkest known world in existence. The planet is not cold. Its surface temperature exceeds 1,000 degrees Celsius, hot enough to glow faintly in the infrared, producing a dim, ominous red thermal emission, the only light it returns to the universe. Scientists have proposed atmospheric absorbers to explain the extraordinary blackness, but none fully account for it. Something about TRES-2b consumes light in a way that remains genuinely unexplained. Imagine standing on its surface. The star filling the sky above you would be invisible. Not dim, not obscured, but invisible, because the atmosphere absorbs essentially all the light before it reaches the ground. Absolute darkness, on a surface baking at over 1,000 degrees. TRES-2b does not merely orbit in darkness. It creates darkness. It manufactures it. Number 7. 55 Cancri e. In 2004, astronomers announced the discovery of a super-Earth orbiting the star 55 Cancri a, approximately 41 light-years away. The planet, now named Janssen, is twice the diameter of Earth and nearly 9 times its mass. Early models suggested the possibility that much of its interior might be composed of carbon under extreme pressure. Carbon under those conditions does not stay carbon, it becomes diamond. Researchers calculated the estimated value of 55 Cancri I at approximately 384 quadrillion times Earth's entire gross domestic product. The headlines described a diamond planet. What the headlines did not adequately convey was the condition of that diamond planet. 55 Cancri E orbits its star in under 18 hours, one of the shortest orbital periods ever measured for a rocky world, placing it so close that the dayside surface temperature reaches approximately 2,300 degrees Celsius. The planet is tidally locked. That hemisphere is not rock. It is an ocean of magma, liquid rock stretching across an entire planetary face, churning under radiation thousands of times more intense than anything Earth receives from the Sun. In 2023, NASA's James Webb Space Telescope detected something that should not survive in this environment, a thin atmosphere rich in carbon dioxide and carbon monoxide. It survives because the magma ocean below is continuously exhaling. The planet breathes lava into space, regenerating its atmosphere faster than the star can destroy it. The most valuable object humanity has ever located is completely, irreversibly, and magnificently uninhabitable. Number 6. HD 189733b. In 2005, a team of astronomers detected a gas giant orbiting a star approximately 64 light-years away and designated it HD 189733b. In 2013, astronomer Tom Evans of Oxford University used the Hubble Space Telescope to determine the planet's true color. It is blue, a deep, vivid, saturated blue, strikingly similar to the color of Earth as seen from space. Something blue felt meaningful. Blue suggested water. Blue suggested atmosphere. Blue, in the language the human brain uses to process color, suggested something familiar. That instinct is catastrophically wrong in the most specifically violent way possible. The blue of HD 189733b has nothing to do with water. It comes from silicate particles in the upper atmosphere, the same mineral family that makes up glass, that at temperatures approaching 930 degrees Celsius condense into tiny molten droplets. Then the wind catches them. HD 189733 3BB sustains atmospheric winds of up to 8,700 kilometers per hour, more than 20 times the wind speed of the most powerful hurricane ever recorded on Earth. Those winds carry the glass droplets sideways in horizontal sheets, scouring the atmosphere continuously. It does not rain glass on HD 189733b. It fires glass. HD 189733b is the universe's most effective trap, a blue world, promising from a distance, lethal on arrival, offering no gradation between appearing safe and being fatal. Number 5. WASP-76b. In 2013, the Wide-Angle Search for Planets Consortium detected an anomaly in the light curve of a star approximately 640 light-years away in the constellation Pisces. The planet orbiting it, WASP-76b, would not reveal its most extraordinary feature until 2020, when the espresso instrument on the European Southern Observatory's Very Large Telescope in Chile analyzed its atmosphere. WASP 76b is tidally locked. The dayside reaches approximately 2,500 degrees Celsius, sufficient not merely to melt iron, but to vaporize it entirely. Iron at the surface does not melt, it boils. The vapor rises, is caught by circulation currents, and is carried across to the night side. There, the temperature drops to approximately 1,000 degrees Celsius, still incomprehensibly hot by any human standard, but cool enough for iron vapor to condense into liquid droplets, and liquid droplets fall. On the permanent night side of WASP 76b, every night it rains iron. The espresso team confirmed this by detecting iron signatures on the day side and finding none on the night side. The entire supply of iron vapor precipitates out before it can complete the crossing. The iron that fell last night evaporates with the next day cycle, rises, crosses, cools, condenses, and falls again. The weather forecast on WASP 76b is the same every day. Clear skies and vaporized iron in the morning. Molten iron rain after dark. Repeat indefinitely. Number 4. WASP 12. B. In April 2008, the SuperWASP survey detected a hot Jupiter approximately 600 light-years away in the constellation Auriga. Its orbit was extraordinarily tight, one full revolution every 26 hours at a distance of roughly 3.5 million kilometers from its host star. Mercury, the innermost planet of our solar system, orbits the Sun at 58 million kilometers. WASP-12 bow orbits at less than a 15th of that distance. Theorists had predicted for decades that planets in orbits this tight would eventually spiral inward and be consumed. What had never been established was observation. No one had ever caught a planet in the act. In 2017, Kishore Patra, then an undergraduate at MIT, examined WASP-12b's transit timing data and found the interval between successive transits was shortening. The orbital period was decreasing by 29 milliseconds every year. In 2019, Samuel Yee of Princeton University confirmed it definitively. A 2024 study combining 12 years of transit data refined the timeline. WASP-12b will be entirely consumed by its star within approximately 3 million years. The star's gravity has already distorted the planet into an egg shape. Its atmosphere has expanded to 3 times Jupiter's radius. It is losing mass continuously. We are not predicting WASP-12b's death in the abstract. We are measuring it. 29 milliseconds per year. The most precisely documented planetary execution in the history of astronomy. Number 3. KELT 9b. In June 2017, the team behind the Kilo-degree Extremely Little Telescope survey published a paper in Nature announcing a discovery that required astronomers to read the number twice. They had found a planet hotter than most stars. KELT 9b, a gas giant approximately 650 light-years away, has a dayside temperature approaching 4,327 degrees Celsius, roughly 10 times hotter than the surface of Venus, warmer than the surface of every K-type and G-type star in the galaxy, warmer than a significant fraction of F-type stars. The host star itself has a surface temperature of approximately 10,000 degrees Celsius, nearly twice the surface temperature of our Sun. At 4,327 degrees Celsius, molecules cannot exist. Every molecule that forms on the dayside of KELT 9b is immediately torn apart by the radiation. The hydrogen that makes up most of the planet's atmosphere exists not as molecular hydrogen, but as individual atoms, only capable of recombining as the gas flows to the cooler night side. Iron and titanium are present not as compounds, but as free atoms, because no compound can survive long enough to form. Research led by the Max Planck Institute found that KELT 9b is losing more than 100,000 tons of hydrogen every second, its atmosphere streaming behind it in a comet-like tail. The planet does not make life impossible, it makes molecules impossible, which is a more fundamental kind of impossible. Number 2. Kepler-70 b. On December 21, 2011, a team led by Stéphane Charpenais published a paper in Nature announcing the detection of 2 planets orbiting a stellar remnant, approximately 3,850 light-years away. The inner planet, Kepler-70b, has an orbital period of just 5.76 hours, one of the shortest ever measured. Its estimated surface temperature is approximately 6,800 degrees Celsius, hotter than the surface of our own sun. The host star was not always what it is now. It was once a red giant, a dying star that expanded outward to many times its original size during its final evolutionary stages. Kepler 70b orbited through that expansion. The planet passed through the extended outer atmosphere of a dying star. By any conventional framework of planetary science, that passage should have destroyed it entirely. The temperatures, the ram pressure, the tidal forces. Any one of these should have been sufficient to ablate a planet down to nothing. Yet something survived. Kepler. 70b, if it exists, is the compressed remnant of what was once a Jupiter-sized world, reduced to smaller than Earth, now orbiting at a temperature that exceeds the surface of the Sun itself. There is an important caveat. Subsequent research raised the genuine possibility that the signals detected were not reflected planetary light, but stellar pulsation modes. The planets may not exist. But consider what it means if Kepler 70b is real. A planet entered the interior of an expanding star and came out the other side, not intact, but present, still orbiting. And if the universe is capable of that, everything we believe about what a planet can endure requires fundamental revision. Number 1. WASP 121b. Discovered in 2015 and studied in unprecedented detail by the James Webb Space Telescope in 2023, WASP 121b orbits a star approximately 880 light-years away in the constellation Puppis, completing one full revolution every 1.27 Earth days. Its dayside temperature reaches approximately 3,000 degrees Celsius. Its nightside sits at around 1,500 degrees. That 1,500-degree temperature difference between the two hemispheres drives atmospheric circulation winds exceeding 16,000 kilometers per hour. A permanent planet. Encircling jet stream moving faster than any wind ever recorded anywhere in the solar system, by a factor of several times. The JWST data published in 2023 confirmed the presence of vaporized iron, titanium, magnesium, and vanadium in the atmosphere. The metals of planetary formation itself, reduced to gas by temperatures that no solid material in the universe can withstand, hurled endlessly around the planet in that ceaseless roaring current. WASP-121b orbits at or extremely near the Roche limit. The distance from a host star, at which the star's tidal forces begin to overcome the planet's own self-gravity and physically tear it apart. The planet's atmosphere has expanded to the absolute physical maximum the planet's own gravity can retain. Every layer above that threshold is being stripped away continuously, claimed by the star. What JWST revealed that no previous instrument could show is that WASP-121b's atmosphere is chemically asymmetric. The eastern and western hemispheres contain detectably different chemical compositions, the distribution of vaporized metals varying between the two sides of the planet in patterns driven by the ferocious circulation, carrying material around it at 16,000 kilometers per hour. A planet so dynamically violent that its own chemistry varies by hemisphere. This has never been observed before. It required a telescope with JWST's sensitivity to detect, and what it shows is a world so extreme that it has developed chemical geography. Different chemical environments in different locations on the same world, driven purely by the violence of its own atmospheric circulation. Every other world on this list is extreme in one specific way, or two or three. Venus is impossibly hot and corrosive with a demonstrated capacity for catastrophic feedback. Gliese 436b is simultaneously burning and frozen. TRES-2b manufactures darkness. 55 Cancri A is the most valuable object humanity has located, and it breathes lava. HD 189733b fires glass sideways at 8,700 kilometers per hour. WASP-76b rains iron. WASP-12b is dying on a measured schedule, counted in milliseconds per year. KELT-9b makes molecules impossible. Kepler 70b, if it exists, survived passing through a star. WASP-121b contains all of it simultaneously. 3,000-degree temperatures on one side and 1,500 on the other, driving winds that exceed anything in the solar system. vaporized metals of planetary formation being hurled around the planet in an endless circuit. An atmosphere expanded to the physical maximum the planet's gravity can hold, with everything above that threshold being actively stripped away. Chemical asymmetry between hemispheres that required the most powerful space telescope ever built to detect. An orbit at the Roche limit, the edge of physical coherence, where the distinction between a planet and a dispersing cloud of stellar debris is a matter of degree rather than kind. It is not the hottest planet on this list. It is not the darkest. It is not the most definitively scheduled for destruction. It is something more precisely disturbing than any of those specific superlatives. It is a planet that exists at the exact outer boundary of what the laws of physics will permit a planet to be, in every relevant dimension simultaneously. Temperature, wind velocity, atmospheric chemistry, orbital stability, mass retention. In each of these dimensions, WASP-121b sits at the physical limit, not merely at an extreme point within the range, but at the edge of the range itself, where the physics that defines what a planet is begins to transition into the physics that defines what a planet used to be. The standard framing for extreme exoplanets is that they tell us something about the diversity of planetary systems, that they demonstrate the range of conditions the universe can produce. WASP-121b does something different. It does not demonstrate diversity. It demonstrates a limit. It is a planet that exists precisely at the point where the universe has not yet decided to reclassify it as something else. A boundary negotiated continuously between the planet's own gravity and the stars, between the forces that hold a world together and the forces that are actively working to disperse it, balanced at a threshold so narrow that the instruments required to measure it were not available until 2021. That is what separates WASP-121b from everything else in this video, and from almost everything else in the catalog of known worlds. It is not a world in the process of slowly moving toward a boundary. It is a world that is at the boundary right now, today, at this moment, sustained by margins so narrow they required the James Webb Space Telescope to resolve. The other worlds on this list tell us what the universe can do to a planet. WASP-121b tells us how little space exists between a planet and nothing. Taken together, these 10 worlds describe a universe that is not indifferent to the objects within it, not in the sense that it has any agenda or intention, but in the sense that it applies its physics everywhere, without exception, without mercy, and without any consideration for whether the result is something a human mind can categorize as sensible. Venus was habitable, and then it wasn't. Gliese 436b is burning and frozen at the same time. TRES-2b has found a way to be darker than dark. WASP-76b has a weather system that requires a new word for rain. WASP-12b is being measured to its death. KELT-9b is dissolving. Kepler-70b may have survived a star. And WASP-121b sits at the edge of existence itself, sustained by nothing more than the physics of the moment. The universe does not produce worlds like these as exceptions. It produces them as demonstrations of what physics looks like at its limits, what happens when conditions push against the boundaries of what matter and energy and gravity can tolerate before the arrangement has to change. Every world on this list is a place where that boundary is visible, where the physics is working at its maximum, where existence itself is operating at a margin so thin that the instruments required to measure it are the most sophisticated tools humanity has ever built. And there are billions of worlds we have not yet looked at. If you want to see more videos like this one, click on the video on screen now and don't forget to subscribe.